Welcome, everybody. Well, we're going to be talking about solution stoichiometry today, and there's another way to convert to moles when you do stoichiometry using molarity. If you recall, molarity is equal to moles divided by the volume expressed in liters. And one way that you could do a stoichiometric problem is if you multiply the molarity by the volume in liters, you can get to moles, and that is the connection with molarity and doing regular stoichiometry. So here's a little flow chart just showing you some of the connections, between grams and moles. We know we use the molar mass to go from one to another. But here's basically on the bottom what I had told you. If you have the volume and the molarity here, you can multiply those two to get moles. Or you could be given the molarity and you could use the volume. It's the same thing, whether it's molarity times volume, or volume times molarity. You're going to use the product of this to get to moles. And then always to go from the given to the unknown, you use the mole ratio. I have a better example here. This one's linear. So let's say you were given the volume and the molarity of the given. I always use A to represent the given. So here I have the volume of the given, the molarity of the given. So molarity times the volume is going to give you the moles of the given. So we're here. And then one of the things that I use is B over A, which is known as the mole ratio, where B is the unknown, and this is where the balanced equation comes in handy. So B is the coefficient of the unknown, what you're looking for. A is the coefficient of the given. And when you multiply by the mole ratio, you get the moles of the unknown. And then depending on the question, you might be asked to find volume or molarity. Let's say we're being asked to find volume. Then they would have to give you the molarity of the unknown. And if you have this information and the moles, you can figure out the volume. If you recall, volume is equal to moles over molarity. So once you get the moles over here, you can put that there. If the molarity is given, you put that on the denominator and you can solve for the volume. Now, this will be easier if I take you through the steps. So here's what we're going to do. This sample problem says what volume, so we are looking for volume, kind of like in the previous problem, right over here. They want to know what volume of 0.250 molar H2SO4 is needed to react with 50 mLs of 0.100 molar of NaOH. So what I'm going to do here is I'm going to notice this is my given. So this is going to be my A. I'm going to label NaOH as my A, and I'm looking for the volume of B. So what I'm going to do is let's go here to the next page here, and I'm going to go ahead and write the equation just like this. And this one was already balanced. That's important because if you don't balance correctly, you get the wrong mole ratio, and we don't want to do that. So we are told that we have a volume of 50 mLs. And we're told here that we're looking for this volume. We are given the molarity of the unknown. It's 0.250. So they also give us the molarity of the known, which is 0.100. If you do the stoichiometry, remember the first step is to get molarity times the volume in liters and change it to moles. Well, we need to change this volume to liters. If you divide by 1,000, it would become 0.05. So the molarity of the given, which we always call A, is 0.100. If you multiply by the volume in liters, you're going to get what we call moles of A, which is 0.005 moles of NaOH. Now, remember we had labeled this as the given. This is the unknown. The mole ratio, or B over A in this problem, is 1 over 2. You could see the coefficient. So the mole ratio is 1 over 2. You have 1 mole, okay, of H2SO4, and you have 2 moles of NaOH. That will cancel over here. Okay, that's moles. So you're basically dividing by 2, and when you do that, you get 0.0025 moles, but now it's moles of the unknown, or B if you want to call it, which is H2SO4. Now, we're not done. If you recall, what they want us to do is they want us to find the volume. Okay? So, over here, I'm going to put this on the side here. Volume is equal to moles divided by molarity. Now, we just found the moles. It's 0.0025 moles. Okay? And the molarity is already given. It's over here. It's 0.250 molarity. So when you do the math, you're going to end up getting 0.0100 liters of H2SO4. Okay? Now, if they ask you to represent the answer in milliliters, you can change it. I'll give you both. Okay? If we multiply by 1,000 here, this becomes 10.0 milliliters of H2SO4. I used 3 significant digits based on the information provided in the question. And there's your answer, either in milliliters or in liters. Now, I'll show you. Here is the solution. Now, they use dimensional analysis, but they followed the exact same steps we did. Okay, they multiplied molarity times volume. They changed the volume, you could see here, into liters. And they got the moles of the given. Here's the mole ratio that I showed you, 1 over 2. And then they got the volume in liters. And then what they did over here is they changed it back to milliliters. And there's the answer that we just got, 10.0 milliliters. So if you look here, a little different the way they did it, but we're following the exact same steps. Okay, so let's do this. I got 2 practice problems for you. First one is, how many milligrams of sodium sulfide are needed to completely react with 25 mLs of a 0.01 molar aqueous solution of cadmium nitrate, and it tells you the precipitate that you form. Well, what I'm going to do here is, let's review nomenclature. Sodium is +1. It's reacting with sulfur. So sodium sulfide would be this when you crisscross. And it's reacting with cadmium. Cadmium is +2. And nitrate. Let me fix that here. So when you crisscross this, you get cadmium nitrate looking like this. Now, this is a double replacement reaction. These two get together. These two get together. So sodium nitrate is a soluble salt, and the precipitate, remember, metals go first. So it'll be CDS, not SCD. And when you balance this, which is very important that you do that, you need to put a 2 here. Now that we have the equation, now that it's balanced, our next step is going to be to fill in the information. Well, according to this, we have 25 mLs of a 0.01 molar aqueous solution of cadmium nitrate. So let's use a different color here. So notice that they're giving us the volume, 25. Okay, let me make that a little clearer for you. And they're also giving you the molarity, 0.0100. All right. And then over here, since this is the given, we're going to call this A. We're going to call this B over here. And on this side, what we have is they want to know milligrams. That's mass. And they want it in milligrams. So this is what we're looking for. Okay? Now, if you recall, molarity times volume gives you moles. But the volume has to be in liters. So when we divide this by 1,000, we need to convert that number into liters. Okay? All right, so let's do the rest on this page. So we said molarity times volume equals moles. So the molarity is 0.0100. The volume in liters is 0.025. And when you do this, you get 0.00025 moles of cadmium nitrate. Now, look at the mole ratio. This is the next step. Notice that the mole ratio B over A is simply 1 to 1. So, our mole ratio is 1 to 1. That means that the number stays the same. It's still going to be 0.00025 moles, but it's now going to be moles of the unknown, or B if you want to call that, which is Na2S, sodium sulfide. Now, we want to convert moles to grams. So here's what we're going to do. Let's find the molar mass of sodium sulfide. There are 2 sodiums in Na2S, 1 sulfur. Using the periodic table, 22.99 is the atomic mass. Sulfur is 32.07 after rounding. And when you do this, you're going to get a molar mass of 78.05. So, to go from moles to grams, you multiply by the molar mass, which we just found. Okay, this will cancel out the moles. According to the equation, we're going to use 3 significant digits. So, when you multiply here, you're going to end up getting 0.0195 grams, okay, of Na2S. But they don't want grams, they want milligrams. So to go from grams to milligrams, what you need to do is you got to multiply by 1,000. So when we multiply 0.0195 by 1,000, you end up getting 19.5 milligrams of sodium sulfide. Okay? Now let's go back over here. That would be choice B. We got 19.5, and the reason is because they wanted the answer in milligrams. Okay? So there's the work for this problem. Now we got one more over here. Practice exercise number 2 has a part A and a part B. In part A, they want to know how many grams of NaOH are needed to neutralize 20 mLs of 0.150 molar H2SO4 solution. We should start off by writing the equation. Okay? So NaOH, which is a base, is reacting with an acid. It's a strong base reacting with a strong acid. This is what is called a neutralization reaction. You're going to make salt and water. That's what happens when you put an acid and a base together and they neutralize each other. You need to balance, so you need to put a 2 here and a 2 here. Okay? And let's put in the information that's given. See, they want to know how many grams of NaOH. So they're looking for the mass of NaOH. We'll call this B. The given in this problem is we are told that we have a volume of 20 mLs of H2SO4. We have a molarity of 0.150 molar. And what we're going to do is, this is the given. We want to change this because remember, in stoichiometry, we want to change it to moles. So molarity times volume in liters gives you moles. Remember, we got to divide this by 1,000. Cannot forget to change this to liters. So when we do that, we're going to get moles. Okay? So let's do this. I think I have some space over here. So molarity is 0.150. The volume in liters is 0.020 liters. That's going to give us 0.00300 moles of H2SO4. Okay? Now this is moles of A. All right, let me go to the next page here and I'm going to finish this problem. So we have the moles of the given. We know it's 0.00300 moles. Okay? And of course the given is H2SO4. So going back, the mole ratio is B over A. Here's B, here's A. So the mole ratio in this problem is 2 over 1. So if you multiply that number by 2, you get 0.00600 moles of NaOH. And then here's what we need to do. We need to find the molar mass of NaOH. Okay, I'll do that over here. So Na, O, and H. Na is 22.99. There's one of them. There's only one oxygen at 16, and 1.01 is hydrogen. When you add this up, the molar mass is 40. Okay? So going back to this page here, to go from moles to grams, what you do is you multiply by the molar mass of the unknown, which is NaOH, 40 grams per mole. And when you multiply, the moles cancel. And we're going to round this to 3 significant digits. You end up getting 0.240 grams of NaOH, and that's your answer for part A. Okay? Now let's go back. There is a part B here. We'll use this page here in just a moment. So part B, they want to know how many liters of 0.5 molar HCl are needed to react completely with 0.1 moles of lead nitrate, forming a precipitate of PbCl2. So the first thing I would do, and I recommend, is write the equation down. Let's do that here. So hydrochloric acid, HCl, is going to react with lead nitrate, just like this. And this is a double replacement reaction. So the hydrogen and the nitrate are going to get together and form nitric acid. That's one of the products. The other product is lead and chlorine getting together. You're going to form lead 2 chloride. After you write the equation successfully, they even tell you it's a precipitate here. You're going to balance. So you're going to put a 2 here and a 2 here, and now you're ready to go. Now, what was given in the problem? Well, let's take a look. Notice that they're looking for liters of HCl. So HCl is going to be what we're looking for. We're looking for volume. Okay? Now, if you notice, they gave you the molarity of HCl. It's 0.500. So they gave us that. Now, what else did they give us? Well, the given is going to be this guy over here. It's A. We have 0.100 moles. Now, what the nice thing about this problem is that your given is already in moles, which means that you can just go from this step and use the mole ratio. So I'll show you what I mean. Here is the moles of the given. Okay, so the given is A, or lead 2 nitrate. The mole ratio is our next step. B over A is 2 over 1. You can see the coefficients there. That's, again, the importance of balancing. And you're going to get 0.200 moles of the unknown this time, which is B, HCl. Our last step is they want volume. If you recall, liters is equal to moles divided by molarity from a previous step. Well, we just found the numerator, and they gave us the concentration, the molarity. So, if we get 0.2 moles, and we divide that by the molarity that was given, 0.500 m for molarity, you're going to get, and I'm going to round to 3 significant digits, I'll use a different color as well, 0.400 liters of HCl. Okay? You can change it to milliliters, and that would be 400 milliliters, or zero point 0.4. Okay, always pay attention to the question if they want it in liters or milliliters. Here it said liters, so we're going to leave it just like that at 0.400. Okay, so this is how you use solution stoichiometry. The only new step is if you have molarity and volume, of course that volume has to be in liters, and you multiply those two, that gets you to moles, and that's your entry point into the stoichiometry flowchart. Okay, so I hope this lesson helps.